Here we have an exponential equation and we have to solve for x in this an exponential equation. I am saying the given equation is an exponential equation because we have variable at the exponent. So in an equation, if we have variable at the exponent, then the equation is called exponential equation. To solve for the variable x in an exponential equation, what we need to do is we have to get the same base on both sides. Once we get the same base on both sides, we can equate the exponents and we can solve for x. Here on the left side the base is 3, on the right side the base is 27, but 27 is a power of 3 because 27 can be written as 3 to the third power. So when I write 27 as a power of 3, that is 3 to the third power, I can get the same base on both sides. Okay, let me do it. So now I'm writing the stuff on the left side as it is, that is 3 to the power of 81 to the x power equals to this 27 can be written as 3 to the third power whole to the power of 3 to the power x. Okay, now again I'm writing the stuff on the left side as it is. Okay, on the right side, here we have base 3 and we have exponent 3. And for this complete stuff, again, we have the exponent 3 to the x power. So whenever we have two exponents like this, what we can do is we can multiply the two exponents using the power of a power rule. So now I'm writing this base 3 as it is. I multiply these two exponents, then I'm getting 3 times 3 to the x power. Okay, now, so here the base on the left side is 3, the base on the right side is also 3. So now two terms are equal with the same base. So whenever two terms are equal to the same base, what we can do is we can equate the two exponents. So then I'm getting 81 to the power of x equals to 3 times 3 to the power of x. Okay, now again we get an exponential equation because here we have variable at the exponent. So again we have to use the same logic, that is we have to get the same base on both sides so that we can equate the exponents and we can solve for x. Okay, for that, let's simplify this expression over here. So here we have 3 to the x power, and for this 3, what is the exponent? So we don't have any exponent for this 3. Whenever there is no exponent, we have to assume there is the exponent 1. Okay, 81 to the x power equals to, now I multiply two terms with the same base. I can use the product rule of exponents. So whenever I multiply two terms with the same base, what I can do is I can take the base ones and I have to add the exponents. So when I do so, I'm getting 1 positive x. Okay, now we have base 81 on the left side and base 3 on the right side. So as I said earlier, so to solve this exponential equation, we have to get the same base on both sides. So 81 actually is a power of 3. So that is 81 can be written as 3 to the fourth power. When I write this 81 as 3 to the fourth power, I'll be getting the same base 3 on both sides and I can equate the exponents and solve for x. Okay, now let me write 81 as 3 to the fourth power whole to the power of x equals to 3 to the power of 1 positive x. Okay, now, so here again we can use the power of a power rule. That is, we can multiply these two exponents. Then I'm getting 3 to the power of 4x equals to 3 to the power of 1 positive x. Okay, now two terms are equal with the same base 3. Since these two terms are equal with the same base 3, we can equate the exponents. That is 4x equals to 1 positive x. I just equated these two exponents because the base on both sides is same. Okay, now we have to solve for x, but here the variable x appears on both sides of the equation. So we have to get rid of the variable on one of the sides. Okay, let me get rid of the variable on the right side over here. So for that, I have to subtract x from both sides. When I do so, this positive x, negative x will cancel out. So 4x negative x will become 3x equals to 1. So now I divide both sides by 3. When I do so, this 3 will cancel. I'm getting x equals to 1/3. I have solved for x in the given exponential equation. The value of x is 1/3.